Okay, so obviously with this one, sine 2x, there's only one option, 2 sine x cos x. There's nothing else you can do with sine 2x. You can only make it 2 sine x cos x. Okay, so we're going to make it 2 sine x cos x. Okay, and then now for 2 cos square x, again, there's like 3 options. 2 cos square x can be 2 cos square x. No, sorry, it's not cos square x, it's 2 cos square x. So again, you can leave it like that. You can say it's 2 cos square x, you can just take it over. So let's do it here already. Let's take it over. Minus 2 cos square x equal to 0. Okay, so now we got a cos x that we can take out. Common factor cos x. So we can put that in the front. Cos x, and then 2 sine x minus 2 cos x equal to 0. Okay, so all we did is we took out the common factor cos x, and then you got 2 sine x minus 2 cos x inside the bracket. Okay, factorize it. So now we can already see cos x must be 0. Okay, cos x must be 0, or 2 sine x must be equal to 2 cos x. Okay. For the bracket to be 0, obviously if you put it equal to 0, you take the negative 2 cos x over, you get 2 cos x. Okay. And now you remember that thing that we did by changing this to a tan. You get a sine and a cos, you change it to tan. So we can divide both sides here by 2 cos x. So when you divide this by 2 cos x, you divide this by 2 cos x, and you're going to get tan x because the 2's cancel out. And here equal to 1. Now it looks kind of straightforward. Okay, if you think about it, tan x equal to 1. It's not that difficult. It's just going to be x equal to, second function tan 1 is 45 plus 180 times n element z. And then for cos x equal to 0, it's at 90. 90 plus 360 times n element z, or x equal to 270 plus 360 times n element z. Okay, so this one, let's just talk about this one, tan x equal to 1. Okay, we know tan is 1 at 45. Second function tan 1, you get 45. So x is 45 plus, remember now tan is 180, the period, not 360. Okay, so this one is fine. This one, now you got to think of the cos graph again. Cos x equal to 0. When you think of the cos graph, if you think of a cos graph, okay, that goes like this. Look at where the cos graph reaches 0. At 90 and at 270. So 90 plus 360 times n is your one option. 270 plus 360 times n is your other option. Okay. And now we got the general solution. Okay, but now after we got the general solution, we got to do now for specific solutions. Okay, so this is where this thing comes into play, this n element z. Okay, so you start with 0, and you put 0 in there, 0 in there, and 0 in there. It's always best to start with 0. So when you put 0 in, you just have 90. When you put 0 in here, you just have 270. When you put 0 in here, you just have 45. And all three of them is between negative 360 and 360. So they all work. So we can say, therefore, x equal to 45, okay, 45 degrees, 90 degrees, and 270 degrees. They all work. Now we go to 1. We want to see which one fits in here. 1. 45 plus 180 times 1 is 225. It's still fine. So 225 is going to work. Then you put 1 in here. 90 plus 360 times 1 is too big. Because then it's 90 plus 360 is 450. It's too big. If I put 1 in here, I go way too big. I'm past 360, so it's not going to work. So 1 only worked for this one. Now I go to negative 1. Put negative 1 in. Negative 1 here is 45 minus 180. Is negative 135, which is fine. So negative 135 will work. Now I can put negative 1 in here. 90 plus 360 times negative 1, which is 90 minus 360, is negative 270, which also works. Negative 270 works. Okay, because negative 270 is bigger than negative 360. Still in the restriction. And then I put negative 1 in here. 270 minus 360 is negative 90. And that also works. Okay, now I go to negative 2. If I put negative 2, remember any integer, any whole number, like if I say negative 2, for instance, n element z, negative 2, let's see. Negative 2 there is going to be too small. Negative 2 there is going to be too small. It's smaller than negative 360. But negative 2 here, 45 plus 180 times negative 2. So 180 times negative 2 is negative 360. And then negative 360 plus 45. Okay, so that's negative 350. Negative 315. So that's also part of the solution. So negative 2 worked for this one, but then obviously negative 3 won't work. Then it's going to be too small. So then you've got all your specific solutions, which is quite a lot, but you have to keep on substituting 1, 2, negative 1, negative 2, 0 until you're past the restriction, and then you stop.